All right, so here I am with Caillou Lee from Flow Design Architects. We're trying to size a very simple beam. There are three main components for uniformly loaded beam that we need to know, or three different things. Number one, we need to know the length of the beam that we're going to be sizing. This one, in this case, is going to be 12 foot 4 3/4, and also the span of the items that is going to be supporting these guys. These guys, we are assuming that the joists are going on this direction. And because they're going in this direction, they're sitting right on top of that beam, typically at 16 inches on center. So that said, we're going to have these members above, in the floor above, right? We're sizing the beam to create an open concept from this kitchen that doesn't have an open concept to this kitchen now that will have a nice island and a nice big run of cabinets, right? So that said, after we've already laid out the design cleanly and accurately, I do know that we're going to be needing some structural columns in here. So I just drew it as a hatch or a field region, knowing that we're going to be needing a column here and a column here to support this. We don't know what this is. We'll call this guy X. So to know X, we need to know what's going to be the length of X, what's going to be the item that's going to be supported. So after that, you open structural program that we use called StructCalc. It's going to be on your desktop, and it's probably going to be called Flow Structural. Do not search for it here. Do not search for it here. Go ahead and use the one that's on your desktop, because that's one that has already been preset and ready for the things that we do. Once it opens up, in fact, I'm going to close it so that we can open it from scratch. More shortcuts in here today. I'm just going to do things from scratch so that you are able to do it on your own. And by the way, there are other videos on our YouTube channel on how to calculate structures. This is one that is relatively simple, and I wanted to do it relatively quickly with Caillou Lee here. So once the software opens, and by the way, feel free to ask any questions. When the software opens right here, that's what it's going to show. And there's all these members right here. These are all the members that you're able to size. We're going to do an uniformly loaded floor beam. There is another kind of beam and another kind of beam, and then there's a ridge beam. The uniformly, the multi-loaded, and the multi-span pretty much will do the same thing for simple. So, but as you get more complex, you will use these guys. This is a simple one. You click on it, and it brings you this table or this new bar. The new bar at the left is going to deal with the material type and strength of the different materials. This is materials options. This will be where we're going to fill out the information we need that we know from our beam. So span of the beam, 12 foot 4. That will be about 12.5 feet. Okay, it's always one more. Like if it is 12 foot 6, it will be 12 point. Actually, 12 foot 6 will be 12.5, but it's 0.5 of a foot. But I always go up. So 12.5, great. And then, in fact, it probably should be 12.4. Just don't undersize it. Always size it a little more. That's what I'm trying to say. Because you don't want to size a beam that's going to not be able to support something because it's 1 inch too big or things like that. So 12.4, anyways, 12.4. We could probably even call that 12.6. So that's your length of the beam. You got that. Great. Now we're going to tell it what it is that's supporting. And it's called tributary width. Tributary width refers to the length of the elements that's supporting. So 12 foot 3 is the tributary width number 1. Doesn't matter the order in which you put it, so long as you are consistent with that. So 12.3, it will be that, and we're gonna do 12.4. That's gonna be the tributary width on one side, and then the tributary width on the other side will be 10.5, 10.6. Okay, it's right here. Oops, sorry, it's right here. So that's it, 10.5. 10.6, that's fine. So you've already told it what's supporting one side, what's supporting the other side, how long it is. Now you need to know what kind of material you're going to be using. Typically, you're going to start with LVLs. That's what you're going to start with. So to find the material, you go in the material here and change the material types and go to structural composites. Structural composites is where the LVLs are. And then LVLs right here. We typically start with the lowest grade because that's the cheapest and more affordable one. This is the grades, the strength of them. There are multiple types of LVLs, but multiple types of structural composite. Now I'm correcting myself. but LBLs is just a type of a structural composite. So here, when you know the layers is how many of them you're going to attach together. So 2 LBLs, 3 LBLs, 4 LBLs. So we'll just do 3 to start with. And as a rule of thumb, I want people to understand that a beam is typically going to be as deep in inches as it is in feet. So if it is 12 foot in length, it will be 12 foot in depth. Makes sense? But in inches, not foot, in inches. My bad. So that's why I'm saying convert whatever the length of the member is into inches, and that number is what's going to be in the depth. It's confusing. I don't know how to say it in a way that will make sense. But whatever the length is, let's say 10 feet, it will be 10 inches in deep. That's a good starting point. That's not a all one size fits all. It's just a good starting point. So we're gonna then we just keep it at 1 3/4 as the layers. We don't want the layers to be too big because then the column will not be able to support. So we leave that as it is. There's gonna be 3 of them that are gonna be 1 3/4, and then we're gonna say 11 1/4 or 11 7/8. We're gonna do 11 7/8, which is the closest to the 12 foot that we'll be talking about. And then you go here to the equal button, and it tells you whether it passes or not. It passes by about 5.1%. That will typically be okay. But the thing is, there are things we don't know about this property. We don't know a lot of things about this property. We don't know what's sitting above it. We don't know if there's a wall above it. We don't know if there's above it. So we want to be very safe. So that said, to be safe, the thing that I recommend is that you go up on the grade and pick the highest grade. And then it's going to go up by 23%. And that will protect you for things that you don't know much about. So I went to the highest grade. The other option would have been to go deeper, and it will be 14 inches the next one. But you don't want a 14-inch deep LBL. It's going to look horrible. If you don't have a high ceiling, you may actually make that space non-compliant because you need a clearing height of about 7 feet or 6 to 8, depending on the location. So after you do this, you save it. It's going to ask you to save the project number. One thing I want everybody to always be aware of is I want you to use the project number as the title. I want that to be the title of every email you ever write about a particular project, always. So I've gotten some emails where it just says 1125 high pipe. But no, I want to know what the project number is, what's the project name, and use that as a header of the email. That way it's easy to find what that is. 121, 18, Dalton Street. I don't know. I can't see the full name because I have it very close right here. But let's see. Another option would be just to simply go into the. I didn't copy it there. But let me just make this bigger. So Dalton Street Newbury Report map beam calculations. Okay, that's it. That's simple. Newbury Port map beam calculations, and the date so that we don't get it wrong. Oftentimes we end up doing 1,000 options of the same thing, and then you don't know which one's the latest, okay? Okay, so that's saved. Now we're not done yet because we need to size the columns that are going to be supporting this beam. To do that, it's really straightforward. You're gonna grab a column right here and the tool for the columns. And it's gonna bring you to a column. We don't know how tall it's gonna be, so 10 foot is about right because most ceilings are about 8 feet, 9 feet. 10 feet will be fine. So 10 feet means it's weaker because it's skinnier. So if it ends up being shorter, it will actually be stronger. Slenderness of the column. And on that sense, I don't start with structural composite. I would start with solid stone. Solid stone are a little bit more affordable. And in this case, you could do 3 2x4s, which are like 3 or 4. You see these layers right here? It's multiple 2x4s together. Now, are they equal? And it will pass. And you're like, yeah, it passed. But no, you have not loaded it. It has no load. You see how it says actual load 0? It hasn't passed. So you're going to go in and you're going to say you are going to support point A of that column, of that beam. And say, okay, no more loading. Now it has the weight of that particular condition. And it turns out that that particular triple 2x4 will not pass under these circumstances. So you go back to materials right here. And you're going to say, well, it doesn't pass. What do we do? You could go to a structural composites, and then you're going to go there and find, well, actually, you could go back to the solid stone and find other options within that if you can. So this was 3 2x4s, 1.5 by 3.5. So what about 1 5x5 square? Turns out that passes by 48%. That's it. Because unless it's a structural composite made out of LBLs and it's engineered, a solid element is stronger than a lot of little pieces of a weaker, right? So it has a lot more integrity. But also, that was going to be 3 together of 1.5 by 3.5. This is a 5.5. It's bigger, right? As an element, right? So that one passes. And then you don't need to do anything else because the same column for one point is going to be the same column for the other point. Not always the case. But in this case, it is. So this I've already named it FLV1 and COL2. So you could just
sorry, one question. If it passed, try to like lower it down to find like cheaper or smaller. Or
yeah, so this is typically you want to try to do the cheaper and more affordable member that you could size. That's good. That's the way to go. So it's easier to buy three 2x4s than to. It's actually cheaper too than to buy one solid sawn. It's actually heavier to carry. 3 2x4s, they carry it little by little. A bigger member, thicker, it's gonna be heavier. Okay.
Okay, got it. Thank you.
So in this case, you could just go easily, very quickly go into here and say COL1. And then you could say COL1. But, one thing I like to add is refer structural report. I'm going to copy that same text in here and put it in here. Okay, great. Again, my arrows, I like them to come like that nicely. Let's make sure this is funny. Like, I don't like how it is. It's like that. Okay, so, I don't like this arrow coming straight because it gets confusing. So I'm just gonna move it. I'm gonna justify it to the right, come from the top, justify right. It always justify in the direction of the arrow. Justify towards the direction of the arrow. Then we're gonna go back to this one. And we're gonna hide all these babies because we don't really care about, well, we do care about this new room that we're basically designing. I didn't mean to design it, but basically we're designing. All right, and that's it. Okay. Oh, I copy column, but it's not. It's gonna be FBL1, something like that. Let me see. Okay. FLB1. FLB1. All right, so that's done. So that now we've already sized this member. We don't have to do anything else. We can probably tell it that all of these guys are gonna be removed. Remove all elements indicated. I don't want to say all. What if they only remove all and they should remove the entire building? So remove elements indicated. I'm being fast and simple. Do not do this like this when you're doing your drawings. You're gonna be more thorough. You're gonna call out every one of them. You're gonna say the names of each one of them. Door, remove hardware, remove this. You're gonna. I'm trying to do this very quickly and very straightforward. And we're not in charge of the architectural design of this project. We're just supposed to size a beam. So we're giving them way more than what they actually wanted. Right. So we're gonna go ahead and stamp this baby real quick. Make sure the stamp shows up. Great. We're gonna say that this was done by DF and checked by DF and Caillou Lee. And the date is 03/14/2023. And the project number is 23121, which is at the very top right here. Okay, so that's good. We can get rid of that not for construction piece. Okay, load and close. We don't have to save that. Okay, no. Right, override the existing piece. Okay, so now we can make a PDF of this. I don't like that they're so, like, we could probably do this in 1/2 an inch. It's so weird, like so tiny. Let's see. Then it's too big. Oh gosh. I mean, maybe, yeah, then it's too big. It just looks like I'm wasting space. Architects are called to utilize space the best possible way. It's our job. So
Mhm.
let's see if we can fit it in somehow. I guess now the text could go inside because it's not that bad. These are decisions you have to be making early on, so you don't get them all wrong. Could we fit it somehow? You know what? I probably wouldn't mind making the existing into like scale. Now, we don't use scales that don't make sense, so I don't want to be doing things on scales that don't make sense. Typical things should be, 1/16, 1/8, 1/4, half an inch, 3/4, depending on the detail level. So we don't want to do that. It's just, yeah, I think we're gonna probably fit it. Um, we want to fit right here. It looks like three brothers and sisters. The more the merrier. So they'll fit together nice. I don't want to get fancy, but this is one of those weird examples where I may be able to just simply do a nice little box. I know it wouldn't work, but I just want to separate them by boxes so that they know what's what.
Oh,
Like, nice little clean boxes. But in this case, we're good here. I would say throw in some detail like on this because we have some typical kind of beam assembly details, how we want it to be attached and things like that. So,
mhm.
the beam to ceiling. They have a name. You probably know which one I'm talking about.
Yeah, I think so. I think I've seen some of them.
So let me see if I can find that real quick. Although I don't want to take so much more time, so we don't we need it. I'm just trying to be saving time with you, but let me see if I can find it. If I can find it. Base cabinet, close valley, consideration, and I don't know. People, rail, transrail, rail, and roof section wood stair, typical roof layout, typical rail, valley fashion, wood stair. Yeah, I can't find it. Well, they are typically already loaded into our drawings too. That's the easiest way to find it. Like if you go to some of our sheets right here, they have already some details
Mhm.
that we use. It's none of these, but let me see. There's none of those. But to finish the structural side of this project, let me just quickly also finish the report because I haven't done the report. So the report's here. You're just gonna go here. Make sure you save, and you can say print, or you could just go here and say print project. That's the one I like the most.
Okay.
All right. So it closes everything. It does its own thing. My computer doesn't like printing the entire project as one PDF, so each member ends up sometimes being like its own thing. But let's see. Hopefully, it does it.
Okay.
But that's how you would do it. You just go print project and beautiful right there. Each project is printed, each element is printed within the project. You're gonna save
Mhm.
as Adobe and you're gonna name it Huawei. It's gonna be the project number. Okay. So 23-121, 18 Dalton Street, Newbury. Well, there you go, it's showing up. So when it shows up, you just delete the dot p so that that's a PDF. All right, and then you save it. It wants you to put password if you wanted to. You don't have to. And it's gonna do it. And then while it does that, I can just quickly come here. I'm only just gonna send this to the client, to be honest.
Mhm.
Yeah, I'm not gonna do like cover sheets or anything like that. It look beautiful. So one thing that makes this more like legit, because it wouldn't be legit without a stamp. So I don't know if you have stamps saved on your Revit, but on your Adobe, but we have our stamp right here. I do. And you just literally can have all of my stamps right here. Eventually, you're gonna have stamps like that too. So you can just save that. Boop. All set. All set. Save the baby. Gone. Okay, so now we're gonna make a PDF out of this one sheet. Control print. Current view only. Make sure it's 24 by 36. Not fit. Not to fit page.
Yeah. Okay.
All right, and then we go here. We save it. And boom chakalaka. You've already done your first. So this will be drawings. I'm gonna call this drawings. Okay, another thing that I don't know if you're aware of, I don't know if you know about it, but I'll show you real quick. By the way, my audio works okay?
Yeah.
So I don't think you're aware that things should be saved on a particular folder. Because I don't know, like I've been dumping things in those folders and I don't see you doing it. I want to make sure we do it. So this set's done. That was a set. That was a profitable set. We get paid for it in a timely manner. It was just one sheet. Beautiful. You know, it's like the deck sets that you're doing shouldn't be more than a couple of pages. Like it shouldn't be a lot of pages. It should be very simple and straightforward. So then we go here back to our project folder. That's not it. Right. But I'm gonna find a project folder. Go to our project folder for this Dalton. We're gonna go to record set. You're gonna create a project folder here on sets 2023-03-14 permit set and calculations. And then you're gonna find your permit set and calculations that I just dumped into the desktop. You're gonna cut it out of there so that you don't run out of storage and to keep things clean. And then you just go ahead and literally go to your emails, copy one of our pre-written emails. You definitely must have access to them. I want you to be able to deliver things to the clients after I've already approved them too. Like go in, I have all of these typical flow emails. This will be for step 4 or last step. Step 4, you just come here, copy all of that. Okay, come here, paste it. You don't know their name, you should know it because it should be on the set. Marcos Reyes. All right, so Marcos, so his email is actually New Aura. All right, I'm gonna add Caillou Lee. I'm gonna add Marco Severino. And I'm gonna come in here. Not that, sorry. I just want to be efficient. So I'm going to copy the name of this file for my title. Boom. It's easy to find. Okay. This doesn't have the review link. If you want to know how to find the review link so that people can write reviews about Flow, you just go and write Flow Design Architects on Google. Very important that we get reviews. Very, very important that we get reviews.
I think I can also copy from one of your other emails.
You can. That's an even better way. But I was just trying to show you where that comes from. So it really comes from here when you say get more reviews on Google. Okay. Okay, you just copy that link right there. And then you can just come here and literally say link. And you just copy the link inside right here. So right here, okay? Now we gotta make sure this is applicable. I hope this email finds you well. I'm pleased to attach the final permit set of drawings for your project as promised. This drawing is the general contractor. In this case, he's the general contractor. So I want to take that out.
Okay.
So I'm gonna say you should be able to begin the application process. Any minor changes can be made during construction and process. If you have any questions regarding blah, 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 for a manager, will coordinate filing invoice or work. We appreciate your business. Beautiful. 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 That's it. Oh, one thing, make sure you attach things because sometimes it happens that we send things and we don't attach anything. I think I did that today. So, my God, what is the email? Right here. All right. So make sure you attach it. The team has already seen it. The office has already approved it. This design's already done. This could be a Taj Mahal. The process is still the same. The process is still the same. And it's 10. Done. You just finished calculating a beam, writing an email, sending it over, doing a report. You got it. Golden. That was it. I need you to be able to do that in the same speed that I was able to do it. Could you do it in the future?
Yeah, I think so.
All right, great. I'm going to
Takes
save
time.
this and I'm going to send the link to you.
Practice.
All right, thank you.
Okay.
Bye-bye. Bye.
Thank you.